The double angle identities for cosine are very similar to what we were doing for the double angle identities for sine. We just have a new toolkit to use. So I've got them all listed up there, and just like the double angle identities for sine, if you scroll down below the video, there's notes that show you a full derivation of these three things and where they come from. So basically the idea is I have a structure again with a cosine of an angle and a sine of an angle, and normal algebra rules won't allow you to solve that because arc cos can't work on sine and arc sine can't work on cos. So I need to collapse this into a single trig thing. In this case it will be cosines. If you're looking at these and thinking they looked very similar, you are correct. The difference is the cosine ones have cos with cos and sine with sine. The sine identities had a sine then a cos with a sine and a cos. So if the sines and coses are blended, you need a double angle for sine. If the coses and sines are paired together, then it's a double angle identity for cosine. So I'm just going to look at this one. I've got cos of a thing, plus sine of a thing, sine of a thing. Well, that's this one here. Cos of a thing, plus sine of a thing, sine of a thing. So I'm going to write this expression as a reduced cosine. So I'm going to end up with cos of, so whichever thing, alpha and beta, the alpha has to go first there. So cos of phi minus pi over 3 equals 1/2. I think in the end, for cosine specifically, it doesn't really matter which one you do backwards because cos is symmetrical around the y-axis. Sketch one and see that that's true. So I'm going to continue with this. In order to finish this, I need to arc cos both sides. So phi minus pi over 3 is arc cos of 1/2. This is, of course, a special triangle value, 1 to root 3. This is pi over 3 and pi over 6. So the angle that has 1 over 2 as adjacent over hypotenuse is pi over 3. So I've got phi minus pi over 3 is either, sorry, I guess I have two solutions. It's either pi over 3 plus 2 pi n, or cosines are positive, C-A-S-T, here and here. So that's the pi over 3 solution. This would be not quite 2 pi, which is 5 pi over 3. And these are, of course, equal to phi minus pi over 3. So I'm just going to solve on this side, add pi over 3 to each side. Pi over 3 plus another pi over 3 plus 2 pi n is 2 pi over 3 plus 2 pi n. And over here, phi would be 5 pi over 3 plus a pi over 3 plus 2 pi n. And 5 of them plus one more would be 6 of them. And 6 pi's over 3 is just 2 pi. That's 2 pi n. So again, very similar to the sine questions. You just had to take this complicated expression, which you normally couldn't solve because it had a blend of two functions, use the appropriate identity to collapse it into a single one, and then solve the problem as you have been for the entire semester. So that's a mean one. If I look at that there, I have my cos and my sine, so it's a blend of those two functions. And because we're in the double angle identities section, I am inferring I need to use one of these things. But I don't have a second cos and I don't have a second sine. So you have to be a little clever with this, and you have to think about your special triangles. So I'm going to show you this one. 1, 1, root 2 for the pi over 4 angle. Do you notice that the cosine of pi over 4 would be 1 over root 2, and the sine of pi over 4 would be 1 over root 2? They have the same value. So that's the trick here, is that I can write cos pi over 4 instead of 1 over root 2, and I can write sine pi over 4 instead of 1 over root 2. So if I could introduce a 1 over root 2 in these two terms, then I'd be able to do that. So I'm just gonna fudge that in. I'm gonna put in cos phi times 1 over root 2 minus sine phi 1 over root 2. And that's okay as long as I multiply this by 1 over root 2 as well. 1 times 1 over root 2 is just 1 over root 2. So if I make this funny replacement from that particular triangle, I would end up with cos of phi, and 1 over root 2 is the cosine of pi over 4, minus the sine of phi, and instead of 1 over root 2, I'm going to write sine of pi by 4 equals 1 over root 2. So I just used some clever little number tricks to take this thing and to build this particular identity. You notice I have a cos of a thing times a cos of a thing minus a sine of a thing times a sine of the same thing. So once I've got that done, I can collapse this as cos of the first plus the second. So that'll be cos of phi plus the pi over 4 that I introduced equals 1 over root 2. And in the process, I ended up making myself a problem that had a tidy special triangle answer. So I'm going to finish this then by taking the arc cos of both sides. So I'll have phi plus pi over 4 is arc cos of 1 over root 2. The arc cos of 1 over root 2 is either pi over 4 plus 2 pi n, and again, cast rule. Cosines are positive here and here, so I need a pi over 4 family that is in this particular quadrant, the 7 pi over 4. Because 8 pi over 4 would be 2 pi, so I need to be just one shy of that. And that's, of course, plus pi over 4 equals that. Phi plus pi over 4 equals that. So if I kick the pi over 4 here, I end up with phi equals pi over 4 plus pi over 4 plus 2 pi n. Phi would be pi over 4, and pi over 4 is 2 pi over 4, which is the same as pi over 2 plus 2 pi n. And on this side, oh goodness, apparently I don't know how to subtract. This would be minus pi over 4 minus pi over 4 is 0. And on this side, 7 pi over 4 minus a pi over 4 plus a 2 pi n. 7 of these minus 1 would be 6 pi over 4, which is 3 pi over 2. So I managed to get the two solutions to this particular expression. And the only way I was able to do it, just like before, is to take this expression that has two functions and collapse them through some mathemagic into a single cosine, which I can actually solve.